Welcome back to channel Madam Wong. Today, teacher will discuss problem solving involving speed-time graphs. Example 16. The speed-time graph shows the motion of a car for a period of 14 seconds. Calculate the average speed in meter per second for the first 6 seconds. Before we find the average speed, we need to find the total distance for first 6 seconds. This is the area under the graph of first 6 seconds. Area for the first 6 seconds can divide into two parts. Part A and Part B. Part A is a trapezium and Part B is a rectangle. So, total distance traveled for first 6 seconds equals 1/2 times 5 plus 10 times difference between two parallel lines 4 plus area B here 6 minus 4 times the height 10. Total distance equals 30 plus 20 equals 50 meter. So average speed equals 50 meter divided by 6 seconds. Average speed equals 25/3 meter per second. B. The value of t if the distance traveled by the car for first 4 seconds is half the distance traveled at uniform speed. The area of yellow color represents the distance traveled by the car for the first 4 seconds, whereas the area of the blue color represents the distance traveled at a uniform speed. Area of trapezium equals 1/2 area of rectangle. The area of trapezium is 1/2 times 5 plus 10 times 4 equals 1/2 times area of rectangle. So area of rectangle is t minus 4 times 10. 30 equals 5t minus 20. 5t equals 50. T equals 10. C. The value of v if the acceleration for the last 2 seconds is 3.5 meter per second square. But from the graph, the speed in the last 2 seconds is not known. So how? For speed time graph, we can get value of acceleration from gradient of the straight line. Acceleration for last 2 seconds same as acceleration for the last 4 seconds because at the same straight line, gradient are the same. So after we know this concept, now we answer the C. Given acceleration equals 3.5 meter per second square. V minus 10 divided by 14 minus t equals 3.5. V minus 10/4 equals 3.5. V minus 10 equals 3.5 times 4. So V minus 10 equals 14. V equals 24. Example 17. The speed time graph shows the motion of two vehicles. Graph OAB represents the motion of Inzamjet Zabadi's car, and graph CD represents the motion of a taxi driven by Mr. Low. The difference between the distance traveled by the car and the taxi in the period of 24 seconds is 160 meters. Calculate the value of V. From the graph, area under the graph OAB is greater than area under the graph of CD. Distance traveled by the car OAB minus distance traveled by the taxi CD equals 160. So area under the graph OAB is a trapezium. Parallel lines are here. The area of the trapezium 1/2 times bracket 24 plus 16 times the distance between two parallel lines V minus 10 minus distance traveled by the taxi CD 1/2 times bracket 24 minus 8 times V equals 160. So 24 plus 16 equals 40. 24 minus 8 equals 16. Then after we solve it, we will get 20V minus 200 minus 8V equals 160. 12V equals 360. V equals 30. Example 18. The speed time graph shows the motion of a van for a period of t seconds. Calculate A. The rate of change of speed in meter per second square for the first 3 seconds. This is first 3 seconds. So the rate of change of speed in first 3 seconds is 30 minus 12 over 3 minus 0 equals 6 meter per second square. B. The distance in meters traveled for the first 10 seconds. Speed time graph. To find the distance, we will use area under the graph. So first 10 seconds is here, the blue color area here. So divide this area into two parts, A and B. Part A is a trapezium and part B is a rectangle. Distance traveled equals 1/2 times the sum of two parallel lines, 12 plus 30 times 3, the distance between two parallel lines, plus the rectangle here, 10 minus 3 times 30. Distance traveled equals 63 plus 210 equals 273 meters. D. The value of t if the magnitude of the rate of change of speed after 10 seconds is the same as the magnitude of the rate of change of speed for the first 3 seconds. So first 3 seconds is here, and after 10 seconds is here. From the graph, the first 3 seconds the speed of the van was increased. We call it as acceleration. The gradient of the graph is positive, whereas after 10 seconds, the speed of the van was decreased. We call it as deceleration. The gradient of the graph is negative. We want to compare the magnitude of both answers. We must put a negative sign at the front of the rate of change of speed after 10 seconds. So here is the negative, we put it. Magnitude of the rate of change of speed after 10 seconds equals magnitude of the rate of change of speed for the first 3 seconds. Negative 0 minus 30 over t minus 10 equals 30 minus 12 over 3 minus 0. So we get negative bracket negative 30 over t minus 10 equals 30 minus 12 over 3 minus 0. So we get negative bracket negative 30 over t minus 10 equals 18 over 3. Negative negative become positive. 30 over t minus 10 equals 6 over 1. 30 6 bracket t minus 10 t over 6 equals t minus 10. T minus 10 equals 5. T equals 15.
Like my video, please feel free to like and subscribe to my YouTube channel. Thank you.